This video is going to be on finding vertical asymptotes of rational functions. A vertical asymptote is just a part of a rational function. It's not something you necessarily see in the function. It is basically a part of the function that x cannot equal, or that the domain cannot equal. So let's just take a look at a basic rational function. Y equals 1 over x. Okay, this is what a rational function looks like because it's got the variable x on the denominator. And so right here, as you look at the denominator, it creates an issue because one of the rules of math is that we're not allowed to divide by 0. So if x equals 0, then y is undefined. And what that does for us is it creates what we would call an asymptote. It creates a vertical line, and in this case, right on the y-axis. If you were to look in the graph, it would create it right on the y-axis, and it would be this vertical dotted line, and we would draw it like that on the graph, and it would be at x equals 0 because the graph could never cross that asymptote. And so when you're looking for vertical asymptotes, all you need to do is set the denominator equal to 0 and solve for x. When you do that, up will come the answers for what the actual vertical asymptotes are. Those will be the x values that make the denominator equal 0. So let's check one out. So taking a look, let's go with y equals 2 over x minus 4. And so y equals 2 over x minus 4. That's our rational function. So if we want to figure out, if we say find the vertical asymptotes, then what we are going to do is we're just going to take the denominator, which is the one on the bottom, and we're going to set it equal to 0. So take x minus 4, set it equal to 0, and solve. So we would add 4, we would get x equals 4. And so your vertical asymptote would be at x equals 4. That would be the value that x can't equal for the domain. So if someone asks you what is the domain of this function, you would say that the domain is x cannot equal 4, because the fact is that an asymptote is a line that the graph approaches but never touches. It's this value that the function will approach but not equal. Let's look at two problems that are a little bit more involved. So they would be these ones. Y equals 3x over x squared minus x minus 2. And then let's do another one. Y equals x squared minus 2x plus 1 over x squared plus 4x. There's a tendency for a lot of students to get confused about finding vertical asymptotes, but what you need to worry about is the bottom, the denominator. You don't, even if there's x's on top and on bottom, you don't need to worry about them. The only thing you need to worry about when finding vertical asymptotes is the denominator. And so when looking for vertical asymptotes, no matter what is going on in the problem, take this and set the denominator equal to 0. So x squared minus x minus 2 equals 0. And so you're going to have to look at that. We're waiting for an announcement here. It's just going to stay in the video. Alright. whether you heard it or not, there was an announcement here at school. So you're going to take the vertical asymptote. To figure out the vertical asymptotes, you're going to take the denominator, set it equal to 0. Now in this problem, and in a lot of the problems that we'll deal with in this chapter, you have a lot of polynomials. So when you set it equal to 0, the best way to find the answer is to factor. So what multiplies to -2 and adds to -1 in the middle? So that'd be x minus 2 and x plus 1 equals 0. And so we're going to find when each of those equals 0. So x minus 2 would equal 0 when x equals 2, and x plus 1 would equal 0 when x equals -1. And so if somebody says, what's the vertical asymptotes? Like me, the teacher, you would say x equals 2, vertical line, dotted line, we'd put it on our graph there, and x equals -1. And those would be the two vertical asymptotes. So let's try this last one. To find the vertical asymptotes, we would take x squared plus 4x, set it equal to 0, and in this case we just take out a GCF. So x and then x plus 4, and that equals 0. And then we're going to set each part equal to 0. So hopefully as you're watching, you're figuring it out. This would be x equals 0. And the vertical asymptote here, you can do it in your head, x equals -4. Good job. Alright, so your vertical asymptotes are x equals 0 and x equals -4. Alright, have a great day.